If you want to move into the higher yields with the higher qualities, the 300, the 350, 400 bushel or more corn, you have to manage the available nutrients for the plant at the time it comes after them. It isn't that we can plant and harvest anymore. Our soils are not healthy enough, our biology is missing, our nutrients aren't happening at the right time. So we end up with 180 and 200 and 220 bushel corn. The potential of the plant is far beyond that. It's not a genetic issue, it's a management and a nutritional issue. If our goal is to produce 400 bushel corn, we're going to need approximately 400 to 480 units of nitrogen through the plant's growth cycle. We're going to need approximately 240 units of phosphate. We're going to need over 500 units of potassium. And we're going to need almost 200 units of sulfate. These nutrients come into the plant at various times in various amounts. So for example, at V6, 6 leaf stage, our plants are small and they haven't taken up a great deal of nutrition. By this time, we've used approximately 10 pounds of nitrogen, or only 2.5% of our total nutrient requirement. On our phosphate, we've used approximately 6 pounds, or 2.5%. Our potassium, or potash, we've used 14 pounds, or we've taken up 14 pounds, at just a little over 2% of the total requirement. And our sulfate, at V6, we've taken up approximately 4 pounds, or about 2% of our total nutrient requirement for sulfate. At V10, our nitrogen has increased to 61 pounds, or about 14% of the total requirement. Our phosphate, we're approximately 26 pounds, but only at 11% of our total requirement. Now this is the interesting thing about our potash, or potassium. We've moved to 165 pounds of uptake, or 31% of our total requirement. And sulfur has moved up slightly to 8 pounds, or barely 4% of our total requirement. What happens in our corn plant at this growth stage between V12 and V17, the plant just prior to that, at V8 and V10, is taking up huge amounts of potassium. Almost 45% of the total required potassium over the plant's entire life is going to be taken up in this 2 to 2.5 week period. It's a massive influx, uptake of potassium. And potassium is going to be the basis for how well we set this ear, how long of an ear we build. By V16, our nitrogen has increased to almost 234 units. This time, we're building the ear. We're up to 53% of our nitrogen uptake in these flex ear genetics. Our phosphate has increased to 115 pounds, or almost 48%. Our potash, we're almost at 400 pounds uptake. We've got 74% of our total potash requirements in the plant at this stage. Sulfur, we're up to 16 pounds and approximately 8% of our total nutrient requirement. At tassel, we've increased our nitrogen to almost 280 pounds, just under 65%. Our phosphate has increased to 146 pounds, or about 61%. Our potash, 450 pounds, 84% of our potassium is in our plant by tassel. And 20 pounds, or 10% of our sulfates are in our plant by tassel. R is reproduction stage. Now this is going into fruiting. Now I'm setting seed. And so at R4, we're up to 368 pounds of our nitrogen, or 84%. We're up to 227 pounds of phosphate, or 95% of our total requirements are in the plant. Potash, almost 500 pounds, or 93% of our total requirements. But look at the dramatic increase in sulfates from tassel to R4. We've picked up 100 more pounds. We have a total of 124 pounds, or 60% of our sulfur coming into the plant at this time. Sulfur is a part of the protein fixation in these plants. It is the basis of 3 very crucial amino acids, and it has to be there. We can lose 20 to 25 or more of our plant yield just by missing our sulfate requirements, and they come in heavy post-tassel. 90% of our sulfate requirements are coming in between tassel and harvest, and they have to be available. At harvest, we want 100% of our nutrients present and having been taken up by the plant. We've got over 400 units of nitrogen, approximately 240 units of phosphate, we've got over 500 units of potash, and we've got our 200 units of sulfate. That is the basis of helping these plants produce these kind of yields. As we look at a plant from the beginning to the harvest, we look at stages where we have these amazing opportunities to make a difference in our environmental quality, our soils, our biology, and then also in our plant nutrition program from the beginning to the end. And we have to look at this. We have put together a basic program to help the plant facilitate its yield potential. Let's start with our pre-plant program. Before planting, we need to look at soil compaction, and we need to get a probe. We need to look at how much pressure we have to exert to get that probe into the soil. Anything over 300 psi, we are reducing the ability of the roots to penetrate those soils, contact surface area, and extract nutrition. If we've got those heavily compacted zones, we need to use adequate tillage to reduce that compaction. And while we're doing that, adding biology into those furrows is a brilliant way of keeping those furrows open from year to year that allows water and air and root movement so that these soils become way more conducive to plant and root growth. Minerals will help reduce this compaction as well. Lime or gypsum, adding elemental sulfur, can also help adjust the mineral balance and reduce compaction. Cover crops are a great mechanism for stimulating biology, breaking up compaction, adding organic matter. These are tremendous tools that help with the next crop coming in preparation for the soil. We need to update our old soil tests, and we need to look at the minerals that we have to work with and the balance between the elements. A Haney test, or a test that look at the PLFAs, the biological respiration, is an important factor. It's the microbes that take these insoluble, unavailable compounds, fix them, and turn them into plant-available nutrition. The healthier the biology in our soil, the higher the quality of our plant nutrition. Sulfur is the 4th most needed element utilized by corn. Lacking sulfur can cost us up to 25% of our potential yield. We have to look at sulfur products and time their application so the nutrients are there when the plant needs them. Seed treatments give this seed a much needed boost in survivability and early germination and vigor. We have a product called Soil Biology Boost that consists of 12 highly beneficial microorganisms, nitrogen fixers, phosphate sequesters that bring in these nutritions that are going to be needed by the plant. We have microorganisms that solubilize a lot of minerals and also microbes that fight pathogens in this root system. And then we have an activator that dissolves the minerals, activates the microbes. This is put on the seed. Everything is dormant until you plant it. And the survivability and the vigor of these seeds will be greatly enhanced by this seed treatment product. Your starter fertilizers are designed to help your plants with that early growth and early nutritional program. Nitrogen is very essential, but we don't want to lose it. We can use nitrogen stabilizers that are very biologically friendly And we prefer those to those who kill microorganisms in your root systems. Phosphate needs to be stabilized. We want to put in 4 ounces of molybdenum in our starter with our nitrogen. Molybdenum increases the efficiency and use of nitrogen by the plant and by the microbes. Micronutrients are often a necessity in our starters to help with seed germination and early plant vigor. Make sure that you have adequate zinc and cobalt and manganese and iron and copper for these early germination and early growth requirements. Adding biology in furrow with compost and mineral teas is an excellent way to boost the biology profile in that root system. Split applying the nitrogen increases its efficiency and its utilization by the plant. Takeoff is a product that stimulates early plant growth and nutrient uptake. We want to make sure that we're planting as soil temperatures are on the rise. At V3 to V5, which is 3-leaf to 5-leaf stage, our plant is determining the number of rows around the cob. We want to see 18 and 20 and 22 and 24 rows around these plants. If the nutrition isn't present, these plants will not put that yield potential in place. At this growth stage, we may be applying our first herbicide application. If you're using something like glufosinate or glyphosate, these are mineral chelators, which strip trace minerals away from plant functions, and that stops plants from working, growing, and developing. We have a new product, Glyphonix, and it is designed to stop the interference with glyphosate-type products from stripping the minerals away from the plant when it is applied. It doesn't hamper the herbicide action of the product, but it does stop the plant from losing its trace minerals that are essential to its continued growth and development. At the V3 to V5 growth stage, we will want to tissue analysis to verify that we have more than 0.42 parts per million phosphate in our plant. We need in excess of 3 parts per million zinc. Also include molybdenum in your plant tissue analysis. If our mineral levels are not adequate, we can apply the zinc sulfate or a phosphate foliar product to increase the nutrient contents within the plant. At V3 to V5 growth stage, apply a foliar micronutrient product with 1 gallon of calcium nitrate with takeoff for early plant energy and nutrition. At this stage, you can apply stabilized nitrogen with a small amount of molybdenum through your Y drops to increase efficiency. If we are going to use a dry product, consider ammonium sulfate, especially where we need the sulfur post-tassel in reproduction. At the V8 to V10 growth stages, we're looking at making nutrient applications to prepare and set up the plant for ear length determination. At V8 to V10, we are looking at our second herbicide application. Again, we want to mix that with Glyphonix to stop the mineral tie-up by the glyphosate. There's a new polymer called Argosy. Argosy allows us to reduce the volume of our herbicides. It increases the efficiency of our herbicide and extends the effects of the herbicide. We want to add the Argosy to reduce the toxicity of the glyphosate in the plant. And at this stage, especially if you are seeing early die-off in the corn, that means corn dying in late August or early September, we need to apply 8 ounces of Empruv with the Argosy with the herbicide. Empruv enhances the plant's immune system to fight Clavibacter, Michiganensis, Nebraskaensis, or Goss's wilt. Goss's wilt is one of the major factors for early die-off of corn in late August and early September. By applying the Empruv early on, we then reduce the effects of this bacterial pathogen in killing and shutting the plant's nutrient system down. Clavibacter, or Goss's wilt, is now in virtually all the seed that is sold. It is virtually in every state that we grow corn, and we are losing yield and quality because of this disease. The earlier we stop it, the healthier the plant, the more extended time into maturity we will get, and the better quality and the better yields will come from this. At this stage, we should be looking at possibly another micronutrient package. If we haven't side dressed on our split applications of nitrogen and phosphate, we need to be doing so. And remember, we should stabilize the nitrogen and phosphate products. We need the molybdenum there. We need not to lose our phosphate through our soil chemistry interactions. At this time, we want to check for corn rootworm. We need to inspect the corn for insect damage and see if any of these potential pathogens are feeding upon our plants and causing stress, which will reduce yield and quality. If we have a history of corn rootworm at V6 to V10, we can apply Safe Strike from Greenspire Inc. as a foliar. As we inspect or scout for insect damage, fields planted with conventional hybrids need to be scouted for ECB. At V12 to V17, if we have managed our nutrition program adequately, we have fortified the plant and enhanced its ability to produce longer ears with more kernels. Prior to tassel is when the second larger application of Empruv is applied. Include 24 ounces of Empruv with 0.25% Argosy RF as a foliar to maintain a high level of plant health and lengthen fill time by 20 to 30%. I believe that an early application of Empruv is greatly warranted with the effects of Goss's wilt. Getting the second and larger application of Empruv on at this time is crucial. You can also use 2 quarts of seed set in this application. If corn borer are present and exist at an economical threshold, add an insecticide or a deterrent with the Empruv to mitigate this problem. At this time, 1 gallon of ammonium slow-release nitrogen is a great application. There are several products, PT21 and Kugler's KQ XRN are also products to look at. Fish hydrolysate at this stage is an excellent application to provide the plant with amino acids to produce yield and quality. What we have noticed in the application of 1 gallon of fish hydrolysate at tassel is we're getting a nice increase in yield and quality in our corn. I believe the value of fish hydrolysate is there are so many finished compounds and components within the material. Rather than being elemental as nitrogen, phos, potassium, calcium, sulfur, which has to be then acted upon by enzymes, which are catalysts to form it into other more finished compounds, which all takes time and energy. Fish hydrolysate has these completed compounds that the plant then uses readily to activate these systems and not having to make all of that using its own time and energy to create those catalysts. I believe these finished compounds are a key in plant activation, hormonal function, and nutrient efficiency to improve yield and quality. Empruv also contains many of these biologically complete compounds that boost the plant's immune system, increase the plant's functioning, and growth stimulators. These aren't elemental components, they're finished compounds that improve plant performance, yield, and nutrient content. Prior to tassel, you will want to stabilize urea with Nutrisphere, which is biologically friendly, as the plant requires ammonium as its nitrogen source after tassel. A corn plant that dies from disease interference in late August and early September does not have the time to transfer the nutrition that it holds in its stalks or its leaves into that ear of corn and into the kernels. And so what we see is a dramatically reduced mineral and nutrient content in the kernels of the plants that die early. Using a backlight, these kernels that are more translucent have a much higher Zen or protein content. They have much greater nutrient density. These kernels that show this translucent light are a direct indicator of better managed nutrition. It also is an indicator that the plant was able to survive that extra 4 or 5 weeks in late reproduction, so that the nutritional content that was taken up and stored in the corn body through the growing season can now be catalyzed into these nutritional components and moved into the grain. When we look at the cloudy or dull kernels, they exhibit low protein. Plants that die early do not accumulate this nutrient density. You can see that in the cloudiness of these kernels. After we have harvested our corn, we have the issue of our corn residue. By decomposing our plants and getting an active biology functioning back into our soil, we're not only returning the minerals that are left in these plants back into a usable form, but we're destroying the pathogenic populations that overwinter on these undigested, undecomposed residues. We then now have the beneficial effects of improving soil structure, improving tilth, improving water penetration and air movement, and reducing compaction for the next crop that we'll be planting the following spring. We need to use 3/4 to 1 gallon of bio-release on this stubble and have it turned under. It needs to be mixed with approximately 15 gallons of another liquid water. It could be compost mineral tea. This will stimulate the microbes, and the decomposition of the residue will begin almost immediately, and we should have virtually no residue by the following spring. It's crucial that we have the available nutrients for the plant at the time it comes after them. These plants have a very, very specific diet, and they do not alter their diet based on our ability or inability to manage these nutrients. They simply take what they can get and cut the yield. And so it's very crucial that we understand what this plant's diet really is and how we facilitate that programming. Because if we're not in sync with this plant, we are working against it, and that is costing us yield and quality.